So what is it about that problem that makes it especially...
Fractions.
Yeah. Fractions are hard, man. So I keep saying this, and especially those of you who have had me for 88 before. There are certain processes, and we learn in math. Math is the description, really, of how things kind of work. And those processes do not care what's in them, right? So when I'm adding two polynomials, what's the idea governing what I do? What am I allowed to do when I'm adding two polynomials?
Like terms.
Like terms. It's all about like terms. $49, right?
Yeah.
Okay. Wait, did I just do this thing? Oh, they make that one. Okay, cool. Let me make it a little easier. So the very, very, very first thing I want to do, no matter what the hell's in there, what do I want to do very first thing? Distribute the negative. Good. See, this guy's going to... Yeah, it'll work. So if I take that negative through... So this becomes plus, negative, plus. Now we normally don't have to do this, but this is a good idea on a problem. I know I can, what can I put together with this? So the one time I might want to kind of move them around is when I have fractions, so then I can focus on, what do I have to do before I can add those? LCD, yeah, good. And what can I put together with this dude? And that's kind of nice. Minus 1/4, minus 1/4. Yeah, minus 2/4, which is minus 1/2. Is that cool? Minus 1/4, minus another 1/4 is minus a total of 2/4, which is minus 1/2. So, again, so let me just write it. So you got minus 1/4 x, and I'll just put right next to it its like term. What goes with the minus 1/3? Those cancel. That's sweet. Now, of course, like I said, before we can add fractions, I need LCD. What's the LCD going to be here? 8. What's this guy missing? 4. So you get 5/8 x cubes plus 4/8. Should be an x cubed there. X cubed. Now these guys already have LCD. What's negative 1/4 x's minus 1/4 x's? That's negative 2/4 x's. Is that cool? Just getting like terms together. So 5/8 x cubes plus 4/8 x cubes is 9/8 x cubed. Minus 2/4 is also known as 1/2 x. There you go. The process doesn't care. It says combine your like terms. We're the ones that go, oh crap, we got fractions in there. In order to combine them, I need LCD. Okay. You guys kind of with me? So the process of combining, adding, subtracting polynomials is all about getting your like terms together, bringing through a negative if I have to. That process doesn't change. All that might change is what I'm adding together. And then however I'm supposed to add those together, that's how I have to do it. I happen to have fractions here. Oh crap. Right? But it's still x cubes go with x cubes. X squares go with x squares, so forth. Is that right? Do you guys see how that works? Okay. Any other questions from? Yeah.
Do 70 on the same page.
Oh, okay. This This one kind of sounds a little weird. So we get a jacuzzi. Number 70? Right, this one jacuzzi? Yes. So 5 foot by 7 foot jacuzzi is installed on an outdoor deck measuring Y by Y. So obviously a math choice there. How big's your deck, Bob? Y squared. Thanks, Bob. So I'm hoping that the weird thing about this problem is we have to assume that the deck is big enough to hold the damn jacuzzi. If the deck is actually 3 feet by 3 feet, I could have a problem if everybody sits on one side. Right? So the idea is here's my Y by Y deck. I got the square deck, and then I'm going to put a 5 foot by 7 foot jacuzzi somewhere on that deck, and it says find a polynomial for the remaining area of the deck. So I call this kind of problem a cookie cutter problem. And this is a really good one for a picture. You got a Y by Y deck, so it's square because it's Y by Y. It's got all the same side lengths. I'm going to put on that a jacuzzi that's 5 by 7. But really, this is the same idea as what I call a cookie cutter problem. It wants to know how much area do I have left if I want to put out there, I don't know, a wet bar or something. Right? Just really tiki torches and lounge and whatever, and who knows. So, if I say there's my area that would be left over, right? So it's a cookie cutter problem. How much area was there before I put the jacuzzi on it? How much? Yes, you do. Y times Y.
Y times Y minus.
So the area before was Y times Y, which is Y squared. And what's the area of the cut? What's the area of the jacuzzi? What's the area that I'm going to take up with something? Yeah, so the area of jacuzzi is 35 square feet, right? 5 times 7. So then how much area is left? Y squared minus 35. That's what I call a cookie cutter problem. You have an area of dough, then you cut a cookie out of it. Take how much area of dough do you have left? Well, what it was minus what you took. So how much area do you have left to play with? Well, what you had minus what you covered with something. Right? That's how much area you have left.
Do you not have to end it, like, with parentheses around it and do feet squared so that we know the answer is going to be feet squared?
Yeah, you can put a little feet squared out there. Okay. So any other questions on the homework? Yeah.
5.3, I think it's 27.
The one with the big table? Say again?
70, not 27, 70.
Number 70?
Yeah.
The one about kidneys?
Yeah.
Okay. All right, so from jacuzzis to kidney donations. I love this because bottom of page 310, they give you a formula, and it's a polynomial. So if you step back and think about it, lines, like x minus 4. Y equals x minus 4. That's an example of a very simple polynomial, right? How do I know it's a polynomial?
No equal signs and there's no exponent.
Not that there's no exponents, it's that the exponents are whole numbers. There's only x to the first power, right? So I know it's a polynomial. So what they've done, now everything that looks like this is going to be some kind of a straight line. They've given us x cubed, let's see, 14, well actually got t's for time. 14.3 t cubed minus 56t squared plus 57.7 t plus 19. and this represents the number of, okay, this is a little bit of background here, but the number of kidney swaps T years after 2003. That's neat. Kidney swaps. Sounds like a new urban legend. T years after 2003. So here's a neat question for you. How many kidney swaps, whatever those are, were there in 2003? That's a question you could answer without any calculator.
20.
Almost? Yeah, it looks like 20, but not quite.
19.
Looking at the equation, you see they made their point a little big.
19.
If you plug in, what would you plug in for T if it's in 2000? How far after 2003 would it be if it was 2003? How many years after 2003 is that? 0. Plug a 0 in for T, the only thing left is 19. So it must have been 19 then. Okay. So when you graph this thing, you end up with this shape. You do real rough shape. Neat. And real quick, let me point out a couple things. Do you guys know what x squared looks like? Most of the time, most people kind of know what that looks like. Yeah, it looks like a U. How many turns does this have in it? 1. For a squared, it has 1 turn. A line has no turns. It just keeps going forever, right? A cube, how many turns do I see? 2. Interesting. So see, remember what I told you about if you tell me the degree of the polynomial, it gives me an idea of the shape of the graph? I told you that the other day. Cool. There's a little bit of insight into that. Right? Gives me an idea of the number of turning points and so forth. Will it go to infinity on one side? You know, that kind of thing. It tells me a lot. All right, so that's all stuff beyond what you need to do for this one. So number 70 says, estimate the number of kidney pair donations in 2004. So if it's 2004, what's T? 1. You just plug a 1 in. Or even better, you just look at the graph they gave you. Right?
Yes.
So if you look at 1 and you kind of estimate where the output is, it looks to be right in between 30 and 40. So I would just say 35 looks to be about right in between. You can check yourself by just plugging a 1 in. Right, that'd be 14.3 times 1 minus 56 times 1, so forth. And see if it comes out to be about 35. I bet you it will. So you have 2 ways to do that problem. You can either use the graph they gave you and estimate it, or plug a 1 in. What the hell? Okay, maybe. Is that cool? Yeah, okay. So if I want to know in 2005, T would be 2, I would just look to see, about where is that output. I would estimate where the output is, so forth. I can say, what year was it the lowest? I would just find the lowest point and go down and see what year that is. Right? So the year that it was the lowest actually looks to be about 2005. It's 2 years, right? Around 2. It's actually 2 is about right here. To be honest. I think it's kind of with me. This is what, if you have to take eventually Math 176 or 170, 175, any of you have to take that eventually. That class is what I actually classify as graphing hell. Not to deter you from taking it, to make you realize that class puts you through the paces for graphing so that when you get to calculus, the graphing ain't nothing. You can focus on the freaking new stuff, right? So this is what you'll be doing a lot of in pre-calc. Oh, yay, Jeff, thanks. I look forward to that. Is there anything else from homework? Yeah. 55 in the same section? This was sort of like what we just did here, but a little more to the point. They give me this here. And then it's evaluate for x equal to 3 and x equal to negative 3. So what does that mean to do?
To do the equation using 3 and
Yep.
again using negative 3.
So this is like part A. You throw a 3 in for x and you do it. Right? So let's try to do part A together, and I'll let you guys do part B. So part A would say, let x be 3. So throw a 3 in there. So wherever I see an x, I'm going to replace it with 3. And again, we've seen this kind of problems before, right? We've seen ay plus b, let b be negative 2, and a is 3, blah, blah, blah. Just replace the letters with what you know they are. And I just got to figure that out. What is 3 cubed?
27.
And then times another negative 3.
Negative
81, I like it. 3 squared. 9 times 7. 63. Don't do 7 times 3 and then square it. That's going against order operations, and you get some a little bit bigger number than you should. Minus 12, minus 8, and just put all that stuff together. So like 38, negative 38. Now do the same thing for part B. Just plug a negative 3 in there. I will tell you this, when you plug negative in, when you square a negative it becomes, but when you cube a negative it stays negative. So be a little careful.
Why did it stay negative?
Because if I have 3 negatives, 2 of them will kill each other. And there's one dude left alive. So any even number of negatives kill it, they all die. Any odd number of negatives, there's always one dude, yay, left alive, right? Okay. All right. So I just want to go through a couple things in chapter 5 before we get to our general review. And to tell you honestly, all right, just make it a little easier on you as far as homework. The test is going to go up through 5-6. You honestly could do up to 5-7 right now, because 5-7 is polynomials with lots of letters in it. But I mean, I could give you a problem like this, and you shouldn't have any real trouble with it. What would you do with this problem here? Yeah, just foil. So again, the foiling process, and I'm going to use the word foil even though I don't like it. I'm just, bless you.
Thank you.
Does not care what's in it. If it's numbers or letters, it doesn't care. It just says each thing gets a turn to distribute, right? So how would this work? Yeah, x squared?
3x.
Yeah, 3xy. I just put it in alphabetical as I go. It makes it easier to identify like terms. Look here, so if I did this minus yx, what do I get here? I might miss that these are like terms, and I often get, I had one guy, I remember, bless you, probably about 10 years ago now, shit, that was just arguing, he's like, those aren't the same. No. And they are the same, they're like terms, aren't they? I just wrote these out of alphabetical order. Y times x is the same as x times y, right? But he definitely was, oh, no, it's not the same. Why would they would have written it the other way. But I can just turn this around. And of course now, there's no question they're like terms. So you put those together, you get
3x squared y.
I'm not multiplying. I'm not multiplying. So I've got 3 of these minus 1 of these. I have 2xy's, yeah. So the only time exponents can change is when I do what? Multiply or divide, right? Because exponents are based on multiplication. When I'm adding, I'm just collecting these things. They stay what they are. I got so many and so many, so I got so many of these things. I don't have any freaking x squared y squares. So don't tell me you only have 2 of them. All right? And then, of course, at the end, minus 3y squared. I was going to say that's kind of David Blaine kind of stuff, but he's had his 15 minutes, it seems like. He's done. I don't know who the next big guy is. All right, so we'll give you a couple here real quick to try out. That's mean to you. Just to stop anybody who's doing this. This first problem, what's the operation? The main operation? Subtraction. Do not start distributing, please to God. Yeah, you really can't. The only time you're going to start distributing is if in the middle it's multiplication. Subtraction just means combine stuff. It just means bring the negative through and get things together. Good dear Lord. Be really careful, especially in a test. You don't want to waste time doing all that. Oh my God. Uh-oh. All right, should have said that earlier. All right. Don't tear your hair out over this one. There might not be much, if anything, to combine. So, what's the very first thing you want to do here? Yeah, bring that negative through. So 4y cubed minus 2y squared plus 3y minus 2. So just all the signs change in that second dude. Yes, sir.
Really confused. That's what you just said not to.
You just say no.
No, I said don't distribute or like FOIL it out. Yeah.
If you say the negative,
Yeah. Right? You definitely want to distribute the negative.
Yeah.
You don't want to distribute 4y cubed and 2y squared. right? That would be a lot of work. All right, it makes me feel a little better. I thought you were doing that. But you're right. I didn't mean to not distribute the negative. You definitely want to do that. You want to distribute that and get your like terms together. You don't want to start multiplying terms together, right? You just want to combine them. So what goes together with this guy? Yeah, the other y cubed. This guy, negative 6y squared. This guy, the y, and then this dude. Yeah. So then 4y cubed plus 2y cubed. 6y cubed, negative 2y squared, minus 6y squared, minus 8y squared, 3y plus y, 4y, minus 2 minus 3.
Minus 5.
Yes, ma'am.
How did you get x like here?
Here?
Yeah.
Because I got negative 2y squared there, and then minus 6y squared there. So negative 2 minus 6, negative 8. And this is, again, this is definitely not where we should be doing. I think I told you guys this the other day. I always get somebody doing that, but that doesn't make any sense. The only time I have to do this is if there was an equals and I want to get it to the other side. These are all on the same side because there's only one side, right? They're just not in the right order. Who cares? I can still put my like terms together. I don't have to move them around the other terms, right? Did I say that the other day or no? I can't remember. Okay. Now this guy is the one you want to start just. What do you get there? A cubed. A squared b, or ba squared. Minus a squared c. Is that cool so far? So just a, b, c, all just get another a squared stuck on them. And then you're going to stick them all with a negative 2b.
Negative 2ba.
Or, yeah, ba or ab.
Negative 2b squared.
Plus
2bc.
And it's a really, really good idea in general just to get used to putting them in alphabetical order as you go. Because then it's a lot easier to see your like terms, right? Are there like terms? No. Yeah, that's evil, Jeff. Because whenever I give a problem like that, people try to force there to be like terms. Like, there's always like terms. I mean, no, there's not always like terms. So I want to give you at least one example we can do together to show you there might not be anything to combine on the next step. There's nothing like, so I just stop. Okay, cool. Can anybody tell me what one thing could I change in here? Then there would be a decent number of like terms to do something with. If I would have made this just a single A, then there would have been like an AB there and an AB there. I mean, do you see what I'm saying? So that A squared is what threw everything off. Evil Jeff. Okay. So that's section, I can't remember now, it was section 5.4. Section 5.5 was multiplication. Section 5.6, I'm not sure why they gave it its own special place. Yes, sir.
I got a question.
Yeah.
You could write, say if you had a squared along with, say, c or whatever, you can write that as a squared c or ac squared?
No.
No.
You could write this as a squared c or ca squared, which is different from what you said, right?
Right.
The c is, I've got to have one c no matter which way I put it. I can't suddenly have two c's. Does that make sense?
Yeah.
Otherwise, you start to get like terms when they aren't really, maybe. Two a's, one c, whichever order you want to write it. Cool. Okay, cool. Here's one that's on the practice test, actually. If any of you have looked at that thing yet. There's one that looks like this. Well, you have to pick the number 3, Jeff. It's your worst number.
He did more than three of us.
So the biggest mistake I see is somebody tries to tell me this is y cubed minus 27.
No.
And that's no good, right? Why can't it be that? Did anybody think it was that? And now they're like,
I
man,
did not think that.
Okay, nobody wants to fess up to that. I don't blame you. I didn't think that all. Because the 3 cannot distribute across the minus. 3 is based. This is based on multiplication, not based on subtraction. They're not going to play well together. So I've got to get myself a way around this. I've got to write it 3 times, like you guys said. And then what do? Now here's where people start to try to get to the answer on the next step. And there's no way you're going to do that. How would you do this? How would you do 2 times 11 times 8? What would you do? 2 times 11 is 22, and then it can work out times 8, right? You wouldn't. Is there any way you just do it all at once? Do it.
No.
When you go, no. Screw you. So for some reason, I guess somebody tried. I can see all these arrows just going all over the damn place. I'm like, you can't. You cannot. You can't even do it with numbers. Why should you do it with variables? So you take these two. What's going on, my boys? And you FOIL those out, and then you're going to multiply the next step, just like there would be 2 steps to this problem. So what do you get when you FOIL this out?
Y squared.
Y squared minus 3y minus 3y plus 9. Good. So you get y squared minus 6y. Careful now, they only cancel if they're opposite. But you do that last step. You guys do that last step. Alright. I just need a wider angle. You'll notice something kind of funny about when you put the bigger dude first. You know, when you have it in a classic format like this, they have variable squared, that variable there, number, and then the variable number. You have this classic format, like a descending order. When you put the big dude first, all your like terms line themselves up. It's kind of nice. You guys see that happening? So when you bring that through, what do you get here? Y cubed minus 3y squared. Right, everybody gets a term.
Okay.
6y squared.
So your y squares put themselves right next to each other.
Minus 18. Plus 18.
Plus 18y. And then this guy gets a term. 9y minus 27. See, that's kind of nice. Your like terms are all just lined up for you. When I had the little dude from the big dude, remember I had to kind of put them one on top of the other, kind of keep track of them. It's not that terrible, but this is kind of nifty. So you get, put a little y cubed dude alone.
9y.
9y squared, good. What's 27y? Minus 27. Yep.
You don't times the -3 with the 6 and the 9?
Multiply? How do you mean?
Like you don't multiply the -3 with the -6, do you? Or?
Of course you do. That's where we got 18y from.
Oh,
Yeah. So I took the y squared through,
okay.
and then I took the -6y through, and then I took the 9 through.
Okay.
Cool. Now you don't have to do that. You could bring this y through to all 3 and this -3 through to all 3. I don't care which way you do it, as long as everybody gets a chance, right? And real quick, one last thing, and then we'll get into the review, just to blow your brains a little bit. I don't know if anybody's ever seen this weird-ass playing around with numbers, but it really is kind of neat. It's called Pascal's triangle. So it must have been some dude named Pascal. Anybody know the computer language C++? Anybody ever heard of that? All right, when I took college, I was the last one to take Pascal, the one that came before C, you know. Anyway, the rest of you guys don't know. But look at the pattern here. Look what's happening. 1 plus 1 is 2. So I keep putting 1s on the outside. 1 plus 2, 3. 2 plus 1. And then 1, 4, 6, 4, 1. And so, I mean, that's, nice if you're bored and you're like really bored. You just play with numbers for a minute. But watch this. If I did this, I'm just going to do it real quick. You guys just don't even write this stuff down. So you get x squared plus 1 is plus 2x. I'm just going to combine my like terms. Then you get x cubed plus x squared plus 2x squared, so plus 3x squared. Plus 2x plus x, so plus 3x, plus 1. What's the coefficients here? 1, 3, 3, 1. 1, 3, 3, 1. So here's the cool thing. If I did x plus 1 to the 4th power, it would be x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. 1, 4, 6, 4, 1. I hope you realize, I appreciate that you're giving me credit for this. It was not me. But do you start to understand why somebody would even want to do this? Because they have a problem where they have something to the 5th power. And I can put more complicated stuff in there. I just have to kind of keep track of it, and I don't even want to get there. But this is a beautiful shortcut. So I don't have to do it. Look how long it took us just to do a cube. Can you imagine a 4th power? That'd be one more step on top of that. Can you imagine an 8th power? Okay. Doing that by hand. So this is a nice kind of shortcut way to do this by hand. Of course, nowadays we have freaking computers that can just calculate anything. But oh well, I still like to know how to do some stuff by hand and quick ways to do it by hand. Do you guys have to know anything about this at all? Even what I said? No. I just want to show you. It's kind of neat. I do that all the time. Okay. So now let's just get into review. Let me go ahead and give you guys the answer key for that practice test. Yeah. Alright, so again, just to remind you guys, if you haven't tried the practice test out yet, do not look at this. It will do you no good to sit there and go, huh? Copy it, that'd be great. But just to sit there and agree with me, I think I told you this before, it's very easy to agree with me on what I've done. But that's not going to get you ready for the test, so just be careful how you use this. If you use it at all, you can do as little or as much of this as you want to. You don't have to turn this in, please, dear God. I've given you all the answers, so I don't need to see it unless you have a question about it. Bless you. I should probably hire somebody with actually good writing to write these things, but oh well. Huh?
Could even give you a C at one point.
Good try. Good try.
Extra credit rate.
Now what you should say is, I'll do the one for your real test, John.
Well, it doesn't matter, because I'm gonna get the passing grade.
3.8.
Yeah.
We have it at 8. You just have written down the parallel resolution, but you also have that you're showing the graph itself.
3B?
Yes.
Yeah, yeah.
So you show an expression, and you show a visualization. But even, so what you're saying is that even if we have parallel lines, you're saying that's no solution in this class.
No. I'm not saying that. I'm saying if you have parallel lines, that's no solution. Period. Not just in this class.
But you showed it, you expressed it.
No, I know. But my point there was, it's just the fact. It's not just this class. It's everywhere. Everything. Right? If there are parallel lines, and you're talking about a system of equations, and you have parallel lines, there can be no solution. Because the solution is defined to be where those things meet.
For the intercept.
Yes. Cool. Yeah.
I thought degree was the highest number on the polynomials. So number 8a, you have degree of 4.
So remember, the degree of a term is the total number of variables I see in that term. So I see in the first term on 8a, I see 2 a's and a y. So that's a third degree by itself. You with me? The degree is defined to be the total number of letters I see in a term.
Right.
So a squared y has a degree of 3. What does the next term have a degree of? 4.
So
The degree of a polynomial is the highest degree term, the highest degree that I see on a term, right? So, let's see. This term has a third degree. This term is a fourth degree, because there's 1a and 3y. So the degree of the whole polynomial is the highest degree that I see. And that's just a way of really quickly communicating to somebody which term could vary the most, which one would grow the quickest. You know, it's the fourth degree, so the highest powers I see in there combine to be fourth in that term, yeah.
So in the term, it's how many variables, and the polynomial is the highest.
The highest degree I see amongst those terms, yeah. Cool.
Highest one?
Right, so you do each term, third, fourth, and then you step back and say, what's the highest number I've written down?
Okay.
Cool. So again, you can work on the practice test. You can work on quiz corrections. We can do stuff up on the board. Remember, this test is going back to section 3.3, because the last test was up through 3.2. So there's graphing stuff on there, perpendicular, parallel, all that kind of stuff.
Can you show an example of the elimination method?
Sure. Elimination method. That's the...
2A.
Yep. No, that's the second algebraic way to solve a system of equations. So you have the graphical way, which is the way we were talking about just a minute ago, where they meet. And then we have an algebraic way. We have two of them. We have substitution and elimination. So an example of the elimination method would be something like, let's make these capital. What do you got, Jeff? I don't know. Let's make this 3, sir. So which variable is slightly better to work with, to kill? Yeah, B, because they already have different signs, and also they have smaller numbers. You know, that's actually helps out too. But the fact that they already have different signs is good, so I'm not going to make some negative mistake when I'm trying to change signs, because that's another place where it's really easy to make a mistake. So what do I have to do then? I've decided to kill my B. What do I have to start doing to get them to die? Yeah, it's going to be like a LCD. And if you want, you can actually write it this way. It might be a little easier to see what else is going on. What do I want to multiply this one by? 2. By 2. And then this one by 3. Because the LCD, of course, is going to be 6. So then I get 4A
minus 6
equals 2. So just double everything. And again, you can put a little 2 next to everybody so you can see what's going on here. I'm going to do 3. So I get 15A plus 6B, 36. Now, if you get to this point and when you add them together, neither variable dies, erase, go back, figure out what you did wrong. Something should disappear. That's the whole point, right? Something should go away now. So when I add these two, 19A, those go away, equals 38. Good. So thank God, looks like Jeff thought about this right. A equals 2. And once you get one variable, you can plug it into either one. A is 2, so if I plug that back into the second one, 5 times 2 plus 2b equals 12. Is that cool? So now I know A is 2, so I can replace A with 2 here. So if I subtract that 10, 2b equals 2, b equals 1. And how should you write that answer?
2, 1.
Good. Alphabetical order. 2, 1. That would be the point where these two lines would cross. Yeah.
When it says determine whether each pair of equations represents a perpendicular line, and then it gives 2x minus 5y equals negative 3 as one of the equations. And then 2x plus 5y equals 4. So are you just putting these in a slope-intercept form by moving the x's? And you.
So why are you doing that?
I just subtracted.
But tell me why you're doing it.
Because all you need is the slope.
Good. Because perpendicular parallel talks about how the slopes relate.
The slopes are reciprocals.
If they are so, then it would be perpendicular. Yeah. I like it. So if I do the easiest thing I could do to see the slope, I don't plug in points and get points and do m equals y2. Oh my God. I solve each one for y, and the slope is just sitting there staring me in the face, right? So I'll see people do that, but tell me, if I get 2/5 as a slope, what should the perpendicular slope be? Negative 5 over 2. So when you do this, so if you do number 1, subtract 2x, divide by negative 5, I get y equals 2/5 x plus 3/5. So in number 2, again, subtract 2x, divide by 5, I get y equals negative 2/5 x plus 4/5. So the only part of those equations that matter for what I'm doing right now is the slopes. Those are ugly, I don't care. Are they parallel, for example? No. They're not the same, are they? Are they perpendicular? Remember, perpendicular does not mean they cross. Perpendicular means they cross at a 90-degree angle. And like we just said, if one slope is 2/5, the other one would have to be the negative reciprocal, and it isn't. So it's not parallel or perpendicular. It's just one of the many, average Joes just walking around trying to make a living. It's not one of these special cases. Is that cool?
So the same line right here.
This one's got a positive slope, but this one's got a negative slope. So one's going up and the other one's going down. But they're not 90-degree angle because they're not negative reciprocals of each other. So it's not parallel because they meet, and it's not perpendicular because they're not negative reciprocals. In this case, they ask specifically, is it perpendicular? And you just say, no. Yep.
Can you do an example of finding a line that is perpendicular to an equation?
I like it. All right.
It's number,
Here, I'll make one up.
this E.
Yeah.
Number 3, or no, 2.
Oh, yeah. Yeah, but that one I got worked out for you already. So let's see. Find the equation of line. That is perpendicular to and has the same x-intercept as I would like it. So people look at this problem and they say there's already two equations of a line. I'm just going to solve one of them. It's got to be the answer. But I mean, I'm trying to make a whole new equation of a line. Now my line has relationships with two other lines. Don't judge. Yeah.
You do the elimination process with that too?
Definitely not. I don't care where these lines meet. I don't care what these two lines do with each other. What I care is my line is perpendicular to him, for one thing, right? What two things do I need for the equation of a line? Slope and a point. If I got the y-intercept, that'd be great. But you ain't going to get it, so we got to...
The 3x minus y was 15 is just there as like a bit of information, so if you figure that out, you'll get the answer. Like you'll get...
I like it. So this only is a bit of information to help me get slope.
Oh, that one. I thought you were...
This is a bit of information to help me get point.
Oh, but they really don't. At the end of the day, once you solve them and get what you want out of them, you don't need them for your
You
life.
throw them away, right? Exactly the way I hope you don't live your life. I usually do away. So my line is perpendicular to this line. So if only I knew this guy's slope, I would know my slope. So really I have these two blank spots here waiting to be filled in with what these things are. So if you do this, if you break a problem into its parts and focus, it makes it a little bit easier to kind of handle. So the first thing I'm going to look for is my slope, and I know that this word really kind of relates slope, so I want to look at this line. How do I get this line slope?
Times the y by 0.
No.
Oh, psych.
How do I get the slope? Solve for y. Get it in the mx plus b form, yeah? So if I solve for y, how do I solve for y?
Minus 2x.
Minus 2x.
Divide by negative 3.
Divide negative 3. So what part of that do I care about?
2/3.
2/3. Means my slope is what?
2.
Negative
Negative
3 over 2. So my slope, negative 3 over 2. I got that.
Okay, so...
Throw him away. And now, what point do I know anything about? Well, my line has the same x-intercept. Okay, that would be a point my line goes through. If I could find that, I could use it. It has the same x-intercept as that guy. So if I find his x-intercept, that's my x-intercept too, right? How do I find his x-intercept?
0 for y.
Put a 0 in for y. Yeah.
On this part, because you got y equals 2 over 3, and then did you flip it back to a negative because...
That line, my line is perpendicular to that one.
Oh, okay.
So his slope is 2/3. My slope is the negative reciprocal. Cool. So this x-intercept, what would be the x-intercept there? Make y, set y equal to 0. So I get x equals 5. So 5, 0. So can I, yes ma'am?
Why did you put 0?
The minute I make y equal to 0, that's going to be that part of the point. What is this point? What does this really mean? This says that when y is 0, x is 5. And this is exactly, when y is making equal to 0, I get x is 5. That point collects that information. That 0 and that 5 go together. They're true at the same time. When y is 0, x is 5. That's what that says. So when you find intercepts, one piece of that point has got to be 0, because that's what you're plugging in. You're plugging a 0 in, and there it's set to be 0. You're finding what the other part is. So I put a 0 in for y. There it is. There it is. I solve for x. Now I fill that part in. So that's the x-intercept of that line. So what's the x-intercept of my line? Same thing, because that's what it said. Yeah.
So over here, that plus 11 over negative 3, and then you turned it into negative 11 over 3.
What's positive 11 divided by negative 3?
Negative.
Negative 11 thirds. Yeah.
So you don't have to put do the 3 into 11 if it's a fraction for the decimal to leave it, but if it was something I could get like a number, you do.
Yeah, then you would simplify it. To be honest, I'm known, and I won't do this to you guys, but I've done this to other classes in the past. I'll put here like 1.927, or I'll put there 13 million, because I don't care what the hell the y-intercept is. All I care about is what that slope is, right? I don't care where that line is. I don't care where the line is. I just care where is he going, because I got to go the direct opposite direction, right? That's all I care about. This is what tells me where he's going. I don't care what the hell it is, really.
Yeah, so, okay, over there on that equation, okay, so if the slope is 3 over 2.
Negative 3 halves?
So yeah, negative 3 halves. And then
No, don't look at that. That has nothing to do. That's a whole other line. Okay. So the only thing that had to do with my slope was that line.
And where do you find the 5 and the 0 for your point?
All right, so now it says the same x-intercept as that line. Okay, now I got to investigate that line.
Oh, yeah. Okay.
Get him to tell me what his x-intercept is, and then that's my point. My line has the same x-intercept as this one does.
You set y to 0.
How do you get the x-intercept?
Set the y to 0.
Set y equal to 0. How do you get the y-intercept? You make x 0. How do you get the x-intercept? You make y 0. If you add a z in there, how do you get the z-intercept? You set the other variable to 0. Whatever the hell. Always. And like I told you, my math 896 class, whatever the hell it was, the last math class I took, I had 27 variables in an equation. I wanted a w-intercept. How did I do it? I made all the other variables 0. And that's silly. I mean, that idea you just learned carries through the next 8 levels of study. It's crazy. Huh? Yeah, that exists. Yes?
So in order to find the perpendicular slope to the given equation, you find the slope to that, and then you just flip it and put a negative.
Negate. So it's the negative reciprocal. Cool.
So what's the actual equation of the line?
We don't know yet. We're just getting the parts. To figure out my line, I need a slope. All right, this is the part of what they told me that related to slope. I used it to get my slope. I need a point. Okay, this is the part that related to point. I used it to get a point. So now I know my line has this slope, and it goes through this point. What can I do with these things? Plug them in. Yeah?
So if the slope comes out negative, you flip it and make it positive?
Yeah. So if one line's slope was negative 1/5, the other one would be positive 5. I love it.
Give us one more just like this. Like this, so we can do
Sure,
it.
but let's finish
Or
this
at
one
least
out.
Even,
So you didn't even need the first equation to find the point.
Oh, hell no.
Yeah, okay, sorry.
Yeah. They'll have to give me 2 separate pieces of information somehow. Either 2 points, and I can find the slope between them, or in your homework you see they give you a point and they say it's perpendicular to this line, and now I've just made it one little tweak harder, but not really. It's still the same thing. Use this to get your slope, and use this to get your x-intercept. And now once you get these, remember that thing? I don't know if I told you guys this. No matter where the hell these two things come from, you do the same damn thing. Right? This is the SDT level. You plug it in. Y minus 0, the y piece, equals m. Negative 3 halves. X minus the x piece. Right, well, this is nice. I'll do that half. You guys do the other half. Equal division of labor. Negative 3 halves x plus 15 halves. Done. Yeah. It is completely possible. And I so am happy. Where are we at? Yeah, no, I am averaging about a 97 on my. Oh yeah, should be -1. Thank you.
And
Wait. So 7a, it should say -1 at the end. And 6 who? Oh, where am I looking? I'm looking at 6e. Yeah, so -2 squared is +4. But -3 cubed is still negative.
oh yeah.
That's all right. So, you know,
So what was the first one?
so the only mistake that we found so far is 7a. It should say -1 at the end. Because you get -2 plus 1. Yeah.
When you were doing slope form, I'm just a little confused with, like, that came out clean because it was y minus 0. Like, I have one that, in the homework, that comes out y minus 8 equals 3/5, and then x minus 2 in the bracket. So what do you do with that 8?
Well, you're going to have to add the 8 over at the end.
Oh, that's all you do is add.
You have to get a little LCD, put it together with your fraction. Yeah, that's all. So this didn't have that last step of adding or subtracting over whatever this is, because there was nothing there. That was kind of nice. But if it was at a y minus 1, I would have had to add 1 to this. I would have made it 2 over 2, 17 halves.
So let's say that in that equation right there it was y minus 2, it would be 17.
Add the 2,
so it'd be
make it 4 over 2, so it'd be 19 halves, right?
Why would it be 19 if you're just adding the 2 onto the y-intercept?
Because it's 2 over 1. You have to have LCD to add fractions. Yeah. So what we're saying is, you'll get to a point, and this is the point where it's true, a lot of people are going to make mistakes on this. But you might have a problem when you get to this point here, y minus 3 equals 2/5 x minus 3/5 or something. Right? So the last step to really clean this up is to add the 3. Well, how do I add these? I got a LCD, so what do I have to do to him? So I get 15/5, so -3/5 plus 15/5, yeah, is 12/5. Right? So do not let that be a problem.
What if you still had a multiplication on the other side and needed to add?
Well, you do the multiplication first. The last thing you're going to do is bring whatever's here over. Because you want to clean this side up first before, it's like you want to clean your house up before this dude comes over. Yeah. Yeah.
I want to make sure I got it for lockdown. So to set, or to find the x or y intercept, you can set the other variable to 0.
Beautiful. Forever. And ever. I like it. Yes, ma'am.
Can you do, equation by itself?
Which one?
Like number 4?
Oh, the substitution? Okay. And real quick, let me show you one example of what I'm talking about. And then we'll do that substitution method. Next semester, no matter, assuming everybody survives my class, when you take 103 or 110, you will get to a point where you will be looking at equations that might look something like this. So you'll have 3 variables, not just 2 or 1. You guys kind of with me? So, what's the matter? So we've certainly done that, haven't we?
Yeah.
Cool. So then you can have that equation. And just to go way too far with this for a second, that's the equation of a point, right? X equals 4 on a number line. That's the equation of a line. This is the equation of a plane. Okay, that's a little too much. That's all right. How do I find the x-intercept? Make y and z 0. So I just had equations with x's and y's and a's and b's and all this other crap. And so what's the w-intercept? Make everything else 0. I mean, these things happen. So I have a, like this wall is a plane. You with me? Is that cool? This wall is a plane, right? Okay. So I want to know, where's that plane hit the x-axis? So then I set y and z equal to 0 to figure out whether that is true. Okay, maybe that's more than we definitely need here, but just to give you an idea of why that intercept thing pleased your God. What makes me sad in my Math 180 class is when I say find the intercept and people have no idea how to do it. So this is true. You guys know how to find the intercept and you will never forget it. So your teachers in the future will love that. It will be one less thing to make them sad. Right? Uh-oh. All right. So now, there's a problem. Let's try one like a substitution problem. Oh, I guess that has to work. Do we have to?
You're not going to give us any formulas, right? Like, I don't know if you understand.
All right, that'll work, huh?
You don't give us any formulas?
No.
Even for the file?
Well, we'll see. But probably not. Pretty much every formula, everything we discuss in this class, pretty much you have to know. Yeah, so the y minus y1 thing, yes, you must know it. mx plus b, you know that already. You got to know that. y2 minus y1, you got to know it. But you can't have a little crib sheet. You can't have it written on your arm. So how do I do this using substitution?
Plug in y.
Yeah. And of course, the nice thing with this problem is it's already solved for x. If it wasn't, I would just take a second and solve for any variable that has a 1 in front. That would be great. So I don't have to have any fractions. So I could put that whole expression in place of x up here, right? So how do I rewrite number 1?
2 parentheses 2y plus 5 minus 5y plus 12.
So just plug that there, and everything else twice that thing minus 5y equals 12. Right, just plug it in there. And now you just solve that. Now you can solve that for y because that's the only variable running around in there. Right? So now you get 4y plus 10.
Minus 5y plus 12.
So I get negative y, and I can take the 10 over there. So y equals negative 2. And if y equals negative 2, x equals what? So the answer would be 1 negative 2. Cool. Is there anything else you want to focus on? Or? Yeah.
Can you do my 6H?
Oh, yeah. So 6H. So we got this here? Yeah.
Did you combine like the 4y minus 5y?
Yeah. So 4y's minus 5y's is negative 1y.
Oh, well, that was, oh, it is negative 1y, I see.
Okay.
For the substitution, they already kind of tell you that they're equal, right? That the set of equations are equal to each other. Just use...
Whenever I'm given a system of equations, they have to be true at the same time always. I don't know if that's what your question is. They won't necessarily give it to me solved for a variable. So if they say use substitution method, I want to solve for a variable if it isn't already done.
Yeah.
So it could have started off with this. It could have said x minus 2y equals 5. I would have added a 2y over first, get x by itself, and then plugged in. Cool. Yeah.
So it's not solving any variable, we can choose any y or x.
Yeah. In this case, I wouldn't solve for y because that would bring in fractions.
Yeah.
And if I have a choice, I'm not going to choose the fraction way. Yeah. What was I about to do?
6H.
Thing.
So,
Stays. Huh?
what if they ask you to eliminate and they give you x, so you just subtract 2y to the other
Yeah, you put it in the right form. So if they ask you to eliminate, and you know elimination should be x's, y's equals number, x's, y's equals number. You force it in that. Yeah. You put everything in the right place. Okay. I'll tell you this. I really just put 6H on there.
Just for fun.
Just for fun. I'm not going to put, I think I told you that last time, that I'm not going to put a question like that on the test. It's a little much to have at one time, but I just want to put it on there just to see if you could try it out. Yeah, just solve inside, flip it, and then square it at the end. Right? But, Eric promised I wouldn't do that. Because the book, I don't think the book has anything quite that level. It does? No, it doesn't. So 6H is worked out. But again, it's... so if I had... Ooh, that's gross. You better watch out. So, like John said, the very first thing I want to do in here, order operations pretty much always saves my ass. Order operations says do in the parentheses first. So the last thing we're going to worry about is a negative 2 power. Yeah, so these have a 7 in common. What's going to move here?
The negative exponent of the a goes down, b goes down.
And very often, it's really weird as a teacher. You want people to focus on doing something, but then you focus a little too much. What just cancels right out?
C's.
Yeah, these. Be careful now. They cancel because they're exactly the same. If that wasn't there, then they wouldn't cancel. You with me? Those 5 would come down, I'd have 10. But since that's there, those are gone. So don't make that part harder than it should be. If they're the same thing, they cancel. But what's going to move here?
The negative 2 will go
Yeah,
up.
those 2 are going to go up.
But now that positive 2 doesn't come back. They don't switch or it stays up
And then
there.
these go down. Yeah. So,
You don't put the positive down below.
no.
You just put that one up.
Then that would basically be, I'd end up with the same exact thing. Yeah. So if those 2 go up and I have 2 already, or should I write it out? Okay. So I had 2 up there, those 2 went up. So these are the 2 that came from below. I had 8 D's down here. Those 4 go down with it. So the last thing I can do on the inside, 6A to the 4, 7B to the 12. What does this tell me to do? It tells me to flip it So what's out here now?
Square. Positive.
Because the only thing I haven't done yet is square. So when I flip it, the negative goes away because it did its job. If the negative was still there, it'd just keep flipping for the rest of it. You know, that'd be crazy. And then you square everything. What do you get inside now? 49. Yeah. When you raise powers to power, you multiply those. So B24. 36. A to the 8th. Good. Not 16. Do you see why somebody might say 16 here?
Yeah.
Because 4 squared is 16, but I don't see 4 in here anywhere. I see 4 A's being squared, so I have A4, that's A8. Yeah, Jim.
When I see a negative, 2 negative exponents, I don't know why it's telling me that you need to combine them and make them negative 10. Even if you swap it, because the rule is to swap it, right? Flip it?
There's 2 rules. There's a negative power means flip.
Flip it, yeah.
And there's also when you divide, you subtract powers.
Oh, okay.
So you could actually do it either way. Both rules are true. So what's negative 4 minus 8? Negative 4 minus 8?
4.
Negative 4 minus 8?
4.
Positive 4.
Get out my calculator.
Negative 12.
Yeah. Negative 4 minus 8 is negative 12.
Oh, negative 8.
Why am I doing minus 8? Because what do you do when
Yeah.
you divide? You subtract. Do you see now how easy?
Yeah.
There's a great example of how easy it is to make a mistake. That's why I choose to just move stuff. Because I know I'm really good at math, but obviously I can make mistakes. So I'm going to try to limit the number of places where I can make a mistake. And negatives are always a good place to make mistakes. But negative 4 minus 8 is negative 12. Since it's a negative, what would you do with it? Flip it. So see how I get B12 on the bottom? So both ways have to agree. It's just which way is a little bit better. Move the negatives so you don't have any negatives floating around. You're not going to make a negative mistake. Do you have to do this? Am I going to hate you if you don't? Hell no. If you'd much rather just use the property, kick-ass. That's beautiful. Nothing wrong with that. Just personally, I think it's easier to do it this way. That's why I do it this way.
So it'd be negative 5 minus
Yeah, negative 5 minus negative 5 is negative 5 plus 5, which is 0. See, that's a lot to kind of carry in your head. Yeah. I'm not saying you can't do it. I'm just saying it's easier to make that mistake then. Yes?
Could you explain to me 8A?
Okay. So I have 2 separate ideas that are related, of course. I got the degree of a term and the degree of a polynomial. So the way to find the degree of a term is by counting the total number of letters you see. It gives you an idea of how strong that term is, how much it'll change as you change the inputs. So what's the degree of this term here? How many total letters? I see 8 A's, 2 B's, 10th degree, 11. No, because it's a 4. It's not a variable. Do I have any control over this 4? No, so it doesn't come into an idea of how strongly the thing reacts to different inputs. Right? These 2 I can directly control. And so this gives me an idea of the strength of the reaction to inputs. And when I put an A in there and a B in there over, it's like a 10th degree. That's how strongly it could react. I know that doesn't make the most sense, but I'm hoping it kind of makes some kind of weird sense. What about here? What's the degree of that term? 4. Yeah, 2 A's, 1 C, 1 Y, so I got 4th degree. Good. I see no variables. 0th degree. You gotta love that word. 0th. So what's the degree of the whole polynomial? Not 14.
10.
10. The highest one I see, the highest degree that I see is a 10th degree. Yep. The polynomial is composed of 3 separate terms. So its degree is going to be the highest one I see.
So it's a 10th degree trinomial?
Good, I love it. So it's a 10th degree trinomial. Yes?
So for the variable, it's now you have like 1 power, but for the number that you have like 1 power.
Again, it totally does, but is for a variable. So it's not going to be in my count of variables. So as I count variables, I'm never going to include the number because it's not a variable. It's set. It can't change. So I can't use it in my measure of how it changes when I change inputs. That's never going to change. This is for. Yeah. Yeah.
Why do we not add all of them up? Why don't we take the biggest number and say it's the 10th degree instead of...
And here's the reason. Why should I add these? Because, let me see. All right. So if I put the same things in for A and B all the time, are you with me? Because what could I make A? What could I make B? Anything. I could make A 3 and B negative 3 trillion, right? What the hell? But what if I made them both always the same? If I put a 5 in for A, I put a 5 in for B, right? Then why would I need A and B? Couldn't I just call them both X? They're both the same always, aren't they? So wouldn't this be X8, X10? Oh, get out of here, Jeff. X2? And what would that be? See me think ahead. X to the 8 times X squared is X to the 10. So that is actually the question you should be asking first is, why the hell would you add those together? They're not the same freaking base. That's why I kind of add them together, because I want to get some kind of feel for how strong this piece would change. And the only way to do it is say, what if I change them by the same rate? The whole thing would react at a 10th power. So that's like a 10th degree term then. We're really overanalyzing this, but you're asking for it. So, now this is separated from that by a minus. Would I ever add these powers together, ever? No, I don't care what situation I'm in. I would never add those together. So the whole idea of a degree of a polynomial is just a quick way of telling me which piece of it is strongest. So the strongest piece I see in there is 10th degree. That's why I don't add those. If I told somebody 14th, that's not, I don't have anything in there that's that strong. That's not really fair. Okay. Yes?
I don't get number 9.
Me either. Wait, that's why I asked that one. I want to see what you guys said. So number 9, I have it referencing the book, right? So it's 3 separate problems.
Oh.
So number 23 from page 283.
Oh, okay.
Yeah, cool. So I got 9, number 23, 9, number 24, 9, number 25. Yeah, cool. Yeah. Thank you. And I solved number 9, the number 24, I solved it using just one variable. You could actually solve that using 2 variables. Now it's just so much easier just to go right to one variable. Yeah.
It says write an equation of the line containing the specified point parallel to the indicated line, and it's the point is 5, negative 4, but then they only give you x equals 2 for the equation. Because I understand when they give you the slope-intercept equation, you just put it in point-slope form and then solve it. And when they don't give you...
So here's a beautiful example of the special cases and how if you try to force them into the same as like any general y plus x or something, it's always going to be way hard. If you realize it's a special case, it should be way easy. I'm not trying to tell you this should be easy, because you don't. It's hard to really remember. It's a special case. X equals 2. What does that look like? That line. X equal to 2.
It's on
so vertical line
at 2.
At 2. Anything parallel to that is also going to be vertical line. So all I got to do is know where is that. Like if I told you, you know, it went through this, it went through 1 right there, and it's parallel to this. Well, what's the equation got to be? X equal 1. Does it make sense? So anything parallel to a vertical line must be an x equals equation. All I have to know is any x part of a point.
And then they give you the 5.
And they give me the 5, yeah. So if it goes through the point 5, -4, that must mean if it's a vertical line, and I know it's a vertical line because it's parallel to this one, it must be the line x equal to 5. Because it goes through 5.
If they just give you the y, it's the same thing. It would just be -4.
Yeah, if they said parallel to y equals 2, then it would be y equal -4. That all I have to do is know one y that goes through, because the horizontal one, the y is always the same. So here, the minute I know it goes through something with the x equal 5, I know the equation is x equals 5, because it can't let x change at all. It's a special case.
And that, because the slope's undefined when it's straight up and down.
Yep. So that's another reason why if you try to force it into y minus 1 equals m, and you're trying to plug into m undefined or infinity, that's definitely not easy to work with. Oh, you guys are staring at me. Now, as always, if you are completely ready for this test, there's absolutely no reason for you to sit there and stare at me, right? I got a few people just looking at me